Hello everyone, welcome back to another class on regeneration biology. So in this class, we will study about how epithelial to mesenchymal transition and reversal of it, that is mesenchymal to epithelial transition, is important during regeneration and also few other biological events such as cancer and development. So this is a change in the identity of the cell. Epithelium to mesenchyme, mesenchyme to epithelium. Let us see how this is contributing for a regeneration context. So, what is epithelial to mesenchymal transition? Very good question. An epithelial to mesenchymal transition is a biological process that allows a polarized epithelial cell, that means a stagnated or a fixed cell, which normally interacts with the basement membrane. That is, we have seen in the earlier class one picture we had where the basement membrane, which is secreted skin basement membrane, which is combined action of your ectoderm and the superficial layer, epidermis and the dermis. So you can refer back the previous class, but understand this epithelium has to have a attachment to the basement membrane via its basal surface to undergo multiple biochemical changes that enable it to assume a mesenchymal cell that exhibits certain properties such as enhanced migratory capacity, invasiveness, resistance to apoptosis, and increased production of ECM component, extracellular matrix components. This is needed for the mesenchyme. So in a nutshell, you can say epithelium is a stagnant cell and the mesenchyme is a migratory cell. So the completion of EMT, that is epithelial to mesenchymal transition, is deciphered by the degradation of the underlying basement membrane and the formation of the mesenchymal cells. Naturally, if you have a dog that is tied onto a pole, so naturally you have to remove the leash for that or unchain it so that the dog can be free. That can migrate away from the original epithelial layer. Simple logic, but it need to have, it's not that an epithelium you can simply detach it because naturally it will undergo apoptosis. But if it is properly got into a mesenchyme, then it will not undergo apoptosis. What happens during EMT? Certain events happen. Let us see what are those events. The epithelial cells lose their surface markers, one of the prominent one being E-cadherin, that is epithelial cadherin. Cadherin is something like that of your legs because you need legs to walk or even hold, or legs and hands. Like if you travel in a crowded bus, your leg should be firm and your hand should be clinging onto somewhere so that you will be on the same spot. If you are not holding anywhere, driver applies brake, you will be out of the bus. So the epithelial cells start expressing mesenchymal markers such as vimentin and N-cadherin, another cadherin molecule that is called N-cadherin or nuclear cadherin. They start expressing. So the epithelial cells produce extracellular matrix degrading enzymes, ECM degrading enzyme. Naturally, ECM is holding the epithelium tight, so you want to get rid of. So the breaking the bond requires some enzymes that will break down the matrix protein so that the cell can be free. And even many matrix proteins like matrix metalloproteases will chop off the extracellular part of the cadherin, E-cadherin, so that it will be blunt. It is not going to have any interaction because the leg is broken, nobody can think of walking, something like that. In this case, you break the leg, that is break the E-cadherin, it can smoothly migrate. So the epithelial cells produce lots of matrix degrading enzyme for facilitating these events. The epithelial cells reorganize their cytoskeletal protein because to move they need to have a specific shape, and the shape of a cell, like normally the spindle shape, the shape of a cell is decided by the cytoskeleton. So it cannot have the same epithelial cell specific cytoskeleton. So it has to reorganize cytoskeletal protein. The epithelial cells begin to express specific cell surface protein, means they are going and interacting with a newer zone or newer niche. So it should be able to interact well. It has to lose its, like if you are going to pole, you will naturally carry some heavy jackets. If you go to polar region without a jacket, then naturally you will perish. So the epithelial cells change the expression of specific microRNAs. We have discussed about microRNAs multiple times. MicroRNAs in general are guardians of a given cell, retaining the identity of that cell, because these microRNAs make sure no unwanted mRNA gets translated, which can cause losing the identity. So the change in the microRNA expression that allows certain mRNA to get translated and the protein can be formed. So you cannot have the same microRNA load what an epithelial cell had. Once it becomes mesenchymal, it has to change. So in this picture, you can see what changes that happens to EMT. So you can see this is an epithelial phenotype. There is a basement membrane, there is epithelial cells arranged, and then there is also some villi that is projecting depending upon which tissue you are talking about. And each adherent, it is connected or to different proteins, ZO1, laminin, intactin, etc. And then also have got a bunch of other identity proteins. These proteins are desmoplakin, MIR200 family, etc. They are not important to memorize. However, these proteins give identity to the epithelial cells. Now they are slowly changing their phenotype. Like you can see here, this is still epithelium. This is lost a little bit. This is lost a little bit. This has completely lost. That is called intermediate phenotypes during the transition. And you can see here, epithelial specific phenotype is yellow. Mesenchymal specific phenotype is green. And you can see the green is slowly increasing. The yellow is slowly decreasing. And the mesenchyme specific phenotype are mentioned here. That is N-cadherin, vimentin, fibronectin, beta-catenin, and OB-cadherin, etc. etc. Name of these genes, and you can see MIR10B. Here it was MIR200, and MIR200 is lost, and MIR10B, which is a microRNA, MIR10B start expressing. So there are other, MIR21 is there, many more microRNAs are there. Some genes like snail, slug, etc. also comes into picture. So these genes retain the identity of epithelium. These genes convert the epithelial cell into mesenchymal cell. So this is what you should understand during this transition. Where does the EMT occur? What are the scenario in which EMT is needed? Epithelial to mesenchymal transition. During embryogenesis, it is needed. During fibrosis, we have seen the wound healing with the scar formation or the prolonged inflammation can cause a fibrosis. During tumor progression and metastasis, during formation of heart, and during the formation of a secondary palate, during various phases of development, and during different cancer progression metastasis, and also during embryonic development, this EMT is necessary. EMT can be classified into mainly three categories, into three subtypes. That is type 1. What is type 1? EMT occurs during development and includes the mesenchymal transition of primitive epithelial cells during a process called gastrulation. Gastrulation is a time where the ectoderm and endoderm is interacting together to give rise to a mesoderm. So this is a process, a very complicated process during embryonic development. And the generation of migrating neural crest cells. Migrating neural crest cells are also formed because in the type 1 EMT from the neuroepithelial cells during the neural tube formation, and the formation of endocardial cushion tissue from the cardiac endothelial cells. So these are all the situations coming under type 1. What is type 2 EMT? That includes the transition of secondary epithelial and endothelial, epithelial as well as endothelial cells to tissue fibroblast, which can be observed during wound healing, regeneration and fibrosis. Type 2 is more prevalent during, type 2 EMT is more prevalent during these events. Now what is type 3 EMT? EMT also occurs in adult tissues and involves the mesenchymal transition of epithelial carcinoma cells, that is during cancer progression, leading to the generation of metastatic tumor cells. That means some may have a tumor originated in the liver, but the secondary may be in the brain, secondary may be in the lungs, and then it makes a very invasive cancer, and that time the type 3 EMT comes into picture. So in nutshell, what we can say, an epithelial stagnated or a attached cell now becomes a migratory cell in a process called EMT, which is done with the help of epithelial to mesenchymal transition process is called like that, but it is facilitated or aided by gene expression events. You can see here type 1, type 2 and type 3 EMTs can be seen. And type 1 you can see, which is primitive streak is a part of embryonic development, and this is the epiblast, and you can see the primary mesenchyme, and this is the hypoblast. So these are formed during embryonic development. And type 2, that is done during the wound healing process. Epithelial cells, basement membrane is there, and you have a mesenchymal cell which is meant for dealing with this wound or injury. Type 3, mainly during cancer, you can see there is a tumor or a mass of tissues here, and some of them are becoming now mesenchyme. Now it is migrating away from this cancer group or a cancer tissue through the bloodstream to a target organ. So this is the three events that is depicted in this picture. Now EMT and fibrosis. So fibrosis, we have seen it is prolonged inflammation can lead to fibrosis. Not that you need to have a wound for fibrosis to occur. Every wound healing with scar formation. Sometimes even regeneration is associated with having some scar in some animals. Some animals have got scar-free wound healing. Some will have a scar that is present. It is also because of the fibrosis or extensive deposit of ECM. So you can see here, this is a normal tissue as you can see here. And the basement membrane is there, E-cadherin expression is there. And what happens? Two category happens, that is resident fibroblast and the inflammatory cell. They influence, due to inflammation, what happens? The TGF-beta, MMP2, MCP1 and also hypoxia, these comes into picture, and they allow this pro-inflammatory milieu or the pro-inflammatory environment stimulate these cells to become mesenchyme. There is no injury, mind it, there is no injury. It is favoring a normal cell to become more mesenchymal specific. As a result, you end up getting a mesenchymal cell formed by EMT. So the EMTs associated with fibrosis are associated with inflammation. Remember, mesenchyme cells are capable of producing too much of ECM, which is a extracellular matrix, which is a feature of fibrosis. And fibrosis is associated with inflammation and the generation of numerous types of molecules by inflammatory cells and resident activated fibroblasts, and which is myofibroblasts. These molecules cause disruption of epithelial layers via degradation of the basement membrane. Remember, pro-inflammation also creates lots of matrix metalloproteases. Naturally, basement membrane will get disrupted. The epithelial cells lose polarity, either undergo by apoptosis, which is in a normal scenario, or by EMT. Any damage happen, cells will undergo apoptosis, but not all. Some of them will survive and they will undergo a EMT transition. That is the minority of the cell. Doesn't matter, they can contribute too much of ECM deposit. And MCP1 monocyte, and another protein is called MCP1, which is full name is monocyte chemoattractant protein 1, which contributes this minority of groups stay in that loci and produce too much of ECM, and it will lead to a fibroid tissue or fibroid tumor or fibroid benign tumor formation can happen because of this EMT. And origin of fibroblast during fibrosis and its reversal by BMP7. Now something interesting. We know our class title is EMT and MET. The moment EMT happens, you know that it should have to have a reversal also. Like you started studying for a course, you cannot say that, I will continue to study for the rest of my life. It doesn't happen because you are studying with a purpose. You have to finish the study and utilize in your life. So that is what happens. Epithelial cell became mesenchymal with a purpose. Its purpose is not to make fibrosis. Its purpose is to migrate, locate in a place, do something, do a job. Either it can be organ formation or wound repair. And then this migrated EMT has to come back to epithelial phenotype. That is called MET, mesenchymal to epithelial transition. This is very important. If this doesn't happen, then there is no there is no purpose of doing this EMT at all. So that is the reversal can happen because of the BMP7. Different sources of fibroblasts are possible in the formation of organ fibrosis. 4 possible mechanisms are listed here in this picture, are depicted. One study suggests that about 12% of fibroblasts are from bone marrow. Fibroblast means we know they are basically the glue tissue. They are the main cells which do not have any unique or a specific function, but they are providing structural stability to a given tissue. And they are 12% are formed from the bone marrow. About 30 can arise via local EMT. That means the epithelial to mesenchymal transition creates the fibroblast, because fibroblasts are the migratory cells involving tubular epithelial cells under inflammatory stress. Some people can, because of food habit or maybe because some abusive use of some chemicals or drugs, or maybe environment pollution, etc., can create an inflammatory milieu. And in old age, normally there can be an inflammatory milieu in your body. And about 35% are from end empty. That is what you can see here, that is formed by some unique stress of mesenchymal transition, that is mainly done because of the stress related inflammation. The remaining percentage likely emerge via the proliferation of the resident fibroblasts and other still unidentified sources. So you can see there are bone marrow derived and end empty, that is endometrial mesenchymal transition that can contribute. And you can see this is the activated fibroblast that has been mentioned here, and this is resident fibroblast, and this is the epithelial cells, they undergo EMT, and as a result you end up getting a pool of activated fibroblasts which are having mesenchymal phenotype. And in B panel, what you are seeing, systemic treatment of mice with renal fibrosis with recombinant human BMP7 reverses the renal disease due to severe attenuation of EMT and end EMT derived fibroblast formation. So BMP7 can prevent, that means this transition of EMT or the production of too much of fibroblast, which can eventually cause fibrosis, remember, can be reversed by BMP7 treatment. So what you understand from here, although whichever tissue you are talking about, it has the potential to give rise to wandering fibroblast by EMT transition, but you have the ability to prevent that formation also. So contribution of EMT to cancer progression. Let us see how it is helping or how it is involved in the cancer progression. So progression from normal epithelium to invasive carcinoma goes through several stages. The invasive carcinoma stage involves epithelial cells losing their polarity and detaching from the basement membrane. That is the initial stage. The composition of the basement membrane also changes, means it no more retains its affinity for the epithelial cell, altering cell ECM interaction. ECM change happened, cell property changed, and cell ECM interaction got affected, and which in turn will bring about a altered signaling networks also, because ECM contributes a lot for the gene expression events in that cell, and ECM also is a good source of various signaling molecules. Due to the change in the property of both, the signaling networks also change. The next step involves EMT, that is epithelial to mesenchymal transition, and an angiogenic switch. That means it is favoring the formation of new blood vessels, etc., because then only the newly formed cells will get the nutrition, facilitating the malignant phase of tumor growth. So the tumor growth need mesenchymal formation or mesenchymal transition helped by the angiogenesis, and this also will contribute, this process EMT as well as angiogenesis contribute to the growth of malignant growth of the tumor. Progression from this stage to metastatic. Once the tumor is big enough, now it will think of exploring newer territory, secondary tumor or secondary cancer. stage to metastatic cancer also involves EMTs, enabling cancer cells to enter the circulation and exit the bloodstream at a remote target site where they may form micro and macro metastasis, which may involve MET, that is mesenchymal to epithelial transition, and thus reversion to the epithelial phenotype. So you can see here basement membrane is there, and some of them have changed their property, and then they have become their proliferation, and then eventually it is getting into an invasive metastatic cells and passing through the blood vessels into a target site. Even in target site, it will retain their identity. The cancer cell, it will not become a new cancer. It will retain its identity of the source cancer, but it will form a secondary tumor. This is what usually happens. And this kind of migration, that means the first formation of the mesenchyme, if it is a mutated or a troublesome cell which do not follow the cell cycle principle, then it can become cancerous, and it has to become a mesenchymal property to increase in cell number, and then it will start migrating to a target tissue. And all these things orchestrate together for cancer progression. And this mesenchyme cell now undergoes a reversal. Otherwise, it will be migrating in the target also. You don't want them to migrate once it is reached the target. Just like you go for a tour, you took your baggage and you cannot keep your bag closed even after reaching the destination. Then there is no point of carrying that bag. You carried the bag just to unpack it. So this unpacking process is called MET. So this mesenchyme in a target cell becomes epithelium again and become part of that tissue, and it will continue to proliferate. It is not going to stop proliferating. It will continue to proliferate, and the cancer will be established in a new section. Why we study this? Because same thing happens during embryonic development and also happen during wound healing or regeneration. The only difference is they are normal cells during development, and also during wound healing. They are not cancerous cells. They are normal cells. Hence, their proliferation is not unchecked. They follow this contact inhibition, etc. rules will be followed. The moment one cell meets the other cell, it will not proliferate on top of that, because they follow this basement membrane rule. They need to have it. Otherwise, a cancer cell don't need. They will climb on one on top of the other. And this is why cancer becomes a problematic scenario, unlike development or regeneration or wound healing. So in MET, what happens, mesenchymal to epithelial transition is a biological process that changes the mesenchymal cells into epithelial cells. It's a key process in development, tissue repair, and disease progression. Disease here we are referring to the cancer. MET is a multi-step process that involves mesenchymal cells becoming tightly linked and polarized epithelial cells. They have to, from a wandering what you call a spindle shaped cell, becomes a properly shaped cell, because cytoskeletal property change, gene expression events change, and they get settled, get attached onto the basement membrane. And it's a reversible process. If a cell became epithelial cell, it can become mesenchyme again. It is just a question of time and question of gene expression. It is a mechanical process that involves the interaction between neighboring cells and the microenvironment. Microenvironment mainly is ECM, what you are referring to. It is orchestrated by transcription factors like snail, twist, and zinc finger E-box binding, that's called ZEB proteins. Many proteins are there, some are listed here, important ones are listed here. They all contribute to this so-called MET, that is mesenchyme back to epithelium. MET is critical for the reprogramming of mouse fibroblast. You know, Yamanaka factors. Fibroblasts are nothing but mesenchyme. Mesenchyme became stem cell. Stem cell means epithelial characteristic into induced pluripotent stem cell. This is MET is what is happening. The mesenchyme fibroblast, with the help of Yamanaka factors, become epithelial cell, which is nothing but iPSC, we call it. MET is a fundamental process to evolution of multicellular organism. Multicellular organism have got orchestration of different cell types and tissues. If EMT and MET is not possible, then you cannot get a multicellular organism. That means development depends a lot, and regeneration and wound healing depends a lot on the EMT and MET. And naturally, cancer also make use of this strategy, development and wound healing strategy, for cancer cell establishment. MET is associated with morphologic and functional changes in multiple endometrial cell types as well. So you can see EMT and MET in detail here. So you can see epithelial cells are there, EMT is there, and mesenchymal cells are here. So, and it can reverse also. Top arrow is EMT, bottom arrow is MET. Stable intact junctions, apical basal polarity is there, and that is lost when it is becoming a mesenchymal cell in the end product. And the mesenchymal stable, no junctions, front back polarity is there. Means they can go either way. They don't have a proper head or a proper tail. It can go either way. Whereas epithelial cell has a head and a tail. So that is what we refer to by polarity. And it can reverse back by retaining these properties. And you can see the markers mentioned here: E-cadherin, N-cadherin, tight junctions, vimentin, extracellular matrix receptors, and extracellular matrix. How they are contributing. You can see here the vimentin, N-cadherin levels are high in the mesenchyme, whereas the E-cadherin and tight junctions are high in the epithelium. And the intermediate stage, they are retaining both these properties little by little. So they are neither mesenchyme nor epithelium. It's a transition stage. Now, MET during iPS cell reprogramming. Several different cellular processes must take place for somatic cells to undergo reprogramming to induce pluripotent stem cells or iPS cells. iPS cell reprogramming is also known as somatic cell reprogramming and can be achieved by ectopic expression of Yamanaka factors or OSKM, OKSM in short form, that is OCT4, KLF, SOX2 and CMYC. Upon induction, mouse fibroblast must undergo MET to begin the initiation phase of the reprogramming successfully. That is, MET has to kickstart. Epithelial associated genes such as E-cadherin, that is cadherin 1, cadherin 3, 4, 7 up to 11, and occludin, and epithelial cell adhesion molecule epicam, and crumbs homologue, that is CRB3, crumbs homologue 3, and were also upregulated before another gene that is induced, that is NANOG. NANOG is part of Thomson factors, also another set of proteins used for reprogramming or making iPS cells. A key transcription factor in maintaining pluripotency. So the role of NANOG is to retain the pluripotent cell as pluripotent. That is, the epithelial property has to be retained, was turned on. Additionally, mesenchymal cell associated genes such as snail, slug, ZEB1, 2 and N-cadherin were downregulated. You don't want mesenchymal property to be retained within the first 5 days of post OKSM treatment, that is Yamanaka factors treatment induction. The addition of exogenous proteins such as TGF-beta1, which blocks MET, mesenchymal to epithelial transition is blocked by TGF-beta in mammals, decreased iPS reprogramming efficiency significantly. So if you put TGF-beta, the formation of iPS will be significantly decreased, or rather MET blocker it is. These findings are consistent with the previous observations that the embryonic stem cells resemble epithelial cells to express E-cadherin. So E-cadherin expressing cells retain their stem cell or pluripotent characteristics. Recent studies have suggested that the ectopic expression of KLF4, another protein that of the Yamanaka factor, in iPS cells reprogramming may be specifically responsible for the inducing of E-cadherin expression by binding to promoter regions of the first intron of the cadherin gene itself, that is CDH1 gene itself. So what you understand, each of these pluripotency factors have their own dedicated role. Some of them are listed here. So each of these factors that are expressed in the mesenchyme contribute, that is the Yamanaka factors contribute in pushing this mesenchyme back to epithelium. So both EMT and MET happens during regeneration as well. So it is basically a property of the embryonic stage itself. So we will study more about the regeneration biology in the next class. Thank you.